Okay, dann willkommen. Welcome to the first lecture. And yeah, today, as you can see, we've been talking about the application of models. And specifically, so we've been talking about sequence-to-sequence models, right? Because the Negroes have introduced them a couple of weeks ago. And you basically have this encoder-decoder architecture where you encode the input sequence to some vectorized sequence of vectors. And you have the decoder, which also regressively encodes the output sequence. And you need this to achieve different. Like if you just do a sequence labeling, for example, you state like the output sequence. And with these two tasks, for example, which we will be talking about today, well, if you move different lengths in input output. Yeah. So today we'll be talking about machine translation, and later my colleague will be talking a bit about dialog systems. Yeah. So we're talking about machine translation, and just so we're all on the same page, we're talking about translation of natural languages. So here on the slide, you'll see that about human languages like German, Chinese, translated from one of the two to another. If you dig around in the literature, you will also find that the techniques from machine translation, for example, there's this one technique which sprung up around 2008 or something. Unsupervised machine translation is called. And there's also some interesting papers which apply these techniques from machine translation to, for example, translation in between different programming languages. So I think for that paper it was C++ and Python. But for today we'll be talking about translation in between natural languages. If you're interested in the other application, you can take a look at the literature. Yeah. So let's talk about the situation first. So you can imagine that, for example, so there's different applications to machine translation. I'll speak about them later. But well, one you can imagine the following situation: you have this kind of article, and if you happen to not know Chinese, it might be just a wall of text, which is incomprehensible. But then for machine translation, you might just be interested in what this article even is about to get the gist of it. And if you apply, let's say with the Google Translate from 5 years ago, the quality, the output quality might not be so great, but might at least get the gist of what this article is about. And so I must say these slides here, I should Professor Nigo. He's the one who originally held this lecture, and I'm using his slides, and these slides, like the following two slides, are already a couple of years old. And as you may or may not know, the machine translation systems recent years are, well, definitely much better than they used to be. And but yeah, some of the problems still apply. So if you, for example, have translation of a German, that already works pretty well. For example, I have a friend of mine who told me sometimes when he tries to write a paper in English and he just doesn't find the right phrasing, he goes to eval and translates it back to German and then back to English, then it might actually turn out better than what he was trying to say. Like, it's exactly what he was trying to say, but better than he could have said it. So for certain situations, the language works pretty well nowadays. But it's not a solved problem yet, and we'll problems and stuff like that. So, like I said, these slides over here, they're from, I think, many years ago. But this might still happen today. So if you're, for example, like in some context, testing or words, yeah, translations might turn out kind of awkward or let's say and even harmful. Yeah, let's keep over this. And so let's talk about why machine translation is even why it's not a solved problem. So like I mentioned, maybe back in the machine translation research maybe started back in the last century, 50s and 60s or something. And back then, people thought it's just a simple cryptography problem, right? Basically, have one code. If you want to shipper text, if you want to print it to clear text, and then did some experiments with some limited vocabulary and some messages. It looked pretty well. They thought, okay, we'll have it solved in a couple of years. We just need some more funding, and then they kept working on it. It turned out it wasn't so easy as they thought. And well, nowadays it's still not really a solved problem. And some reason for this is that, well, there's lots of ambiguity in language. And let's say we have the German, the English word bank, and it might refer to different meanings, has the same surface form, like the same spelling in context, but it might refer to different words in different contexts. So here's the bank where you store your money, or it might also mean the river bank, translated to from German. The translations are different. Yeah, they're different. Or another example is that, well, another example here on the slide is that, for example, in Japanese, there's 4 different words for rice. And depending on what exactly you're referring to, when you translate it to English, they have different meanings. And when you translate it to English, then it's just one single word for all 4 of them. And so you lose some information while translating. And the same way if you translate from English to Japanese, then if you're missing this information, you don't know which one to translate to. I think actually a much better example than this is, for example, the different politeness level. And for example, in German, there's and stuff like that. And it exists in many languages, but it just doesn't exist in English, right? So if you translate from German to English, that information is lost. And also the other way around, if you have an English sentence, let's say the lecture translator, then usually in this sort of lecture setting, you want to have some sort of polite language, right? So you usually want to translate to Z form. But that has to be inferred from the context, right? And that's maybe something that machine translation system are still struggling with, and it's an open research question. Okay. Yeah. Any question? Let me check. Is it still problematic? Oh yeah, it seems like the wrong microphone was selected. What about now? Is it better now? Yeah, it was better just now because I came closer to the computer. But now I switched the microphone. Yeah. Yeah, so if I'll keep talking for now, and if it's too bad, then maybe we can again. So about the use cases for machine translation. So we have 3 use cases described here. One of them is called assimilation. So we, like this article earlier,
we have some text which we do not understand and we want to understand the content. And the other one is this animation where we want to generate some, for example, have a text in our native language, and we want to translate it into the other language for others to read, and then we want to generate some text in the other language. And there's some different requirements for these two use cases. So one of them is basically just want to understand if the output text in your own language, in your native language, doesn't have perfect grammar or something like that, but you still understand it, then it's usually perfectly fine. But for the dissemination, usually we want it to be beautiful text. And the grammar, aesthetic, and stuff like that. And the last one is the dialogue. Maybe will you be saying something about dialogue machine translation, or yeah? Will you mention something about machine translation? I'll see. Anyway, but yeah, my colleague will be talking about dialogue later. Whether he talks about machine translation or not, we'll see. So yeah, okay. So about the languages. So one important question to ask and answer is how many languages are there even, and what's the situation with especially with how much resources we have for each of the languages. And so people are estimating, linguists are estimating that there's around 67,000 languages in the world. And it's not really clearly defined what is a language and what isn't. I mean, if we, for example, look at Swabian, probably we can say it's not a language, but a dialect, right? But if we look at, Swiss German, I think opinions differ on whether it's a language or not. Yeah. And now here's a map of languages in Europe. And the thing is now Europe has actually not so many languages compared to other continents. Like I've heard that, I think I've read somewhere that just alone Indonesia has a couple of hundreds of languages. And the thing is, when we want to do machine translation from text to text, of course, we make the training data. I'll talk about training data later. But yeah, we want to have these text, parallel text. And the thing is now, many of these 7,000 languages are actually, they don't have a script, they don't have a writing system. So we cannot actually have data in the written form for them. We either have to make up some transcription for them, or we'll maybe do transcription directly or translation directly from audio. But yeah, what else? You can ask the question also, shouldn't we all speak just English? And the answer is, well, by doing that, we exclude, in some countries we do it, maybe 3/4 of the population. And you can see that in some countries, there's, yes, basically everyone knows English, but unit of European Union seems to be around 40% of the population only know English. And, yeah. Okay, now, so about the approach of the machine translation, how to actually do it. So like I said earlier, there used to be these rule-based systems back in the, previous century. And you would do these sorts of, for example, parse trees, where you define these grammars for different languages, and then you parse the grammar and build this tree representation, and then maybe to translate it to a different language, tree translation and stuff like that. But it's a lot of work, and it doesn't actually really work that well because real spoken language or real language doesn't really fit into these rules that well, and there's just too many exceptions. And so what people started doing is using these purpose-based approaches, so basically statistical approaches. where you have large amount of data and you just estimate different statistics from these data, and then yeah, statistically. And there we had, well, we're in the the neural networks lecture, so we'll be talking mostly about well, only about the neural MP. But until around 2014, the most prominent one was the statistical MP. And I mean, actually, many people say that you can also use neural network-based approaches as statistical ones, but we tend to call them purpose-based MP. Um, the general concept is. And yeah, statistical MP started around the 90s, I think, or the 80s. And then around 2014, the attention mechanism was, or let's say the with end-to-end sequence-to-sequence translation models were introduced, and then things started evolving into neural network-based approaches. And nowadays, they're basically only used. Yeah, maybe one thing to mention is one thing those purpose-based MP approaches have in common, that you basically do on the purpose maximum likelihood estimation. Or maybe in the case of neural MP, it's more accurate to say that it's iterative likelihood maximization, but yeah. Okay, so about the data. So basically what you always, or what you usually need to do machine translation is have a so-called parallel corpus. Parallel corpus is